All right. I'm going to do a modest sort of a project. Um, I'm looking at water tanks, and I've got some ideas, but I'd kind of like a better view of the options. So I'm looking at this website, tankmart.com, and they've got a bunch of options, but it's kind of difficult to sort through. So what I want to do is I want to use some web scraping to get this into R to be able to compare tanks, really looking at capacity per dollar or cost per gallon. So with that, let's go ahead and set up a new project. Oh, let's also make sure that my microphone is on. Check 1, 2. That seems fine. All right. Oh, hey, look at this. I've got a sample project already set up. All right, so let's go ahead and set this is tank, water tank web scraping project. All right, so let's say base URL will be tankmart.com. I will use, oh wait, I'm writing code. Let me, library, tidyverse, harvest, that's good enough. My mouse being funny. All right, what's my commit message? That's fine. All right, so water storage tanks. This is what I am looking for. Cool. So if I go like this, cool. So, now, oh, is this everything? This is 100 products. I don't need 1,000 gallons. All right, that's fine. Let's just see what I get. All right, so table is going to be, let's say page is going to be read HTML from paste 0, base URL, and water tank URL. Why am I separating them? I don't know. Sometimes you just overcomplicate things and I can simplify that later, but let's make sure it works. So I think HTML table from page should do the trick. That was so easy. That was almost stupid easy. All right, so now we've got price as a character. So let's go ahead and modify that. So if I say table, mutate, price lowercase equals string remove from price, the pattern $, and then let's have that as dot numeric. Let's see what happens. Not going to work. Class list. Okay, so let's try this. As Tibble, names can't be empty. Hang on a sec. You shouldn't be making sounds. All right. If you're listening to me, apologies for not having some royalty-free music for you to listen to. Some of this most of this is going to be me just going, huh. But play it like double speed and put something on in the background and whatever. You'll be fine. This is more about watching me suffer than it is learning anything directly. All right, so let's look at what is table. It's a list of 1. Okay. That's better. That didn't do what I wanted. Do I need to do that? Nope. Let's try this. This will be cool. All right. So okay. This is not something that it's reasonable for you to know, but as long as we're here, text is super important. For a computer, we know it's all ones and zeros, but we also combine those ones and zeros, right? A 1 and a 0 is a bit. 8 of those together is a byte, and a byte is enough to give you letters. So with a byte, you've got, let's just do a simplified half byte. We got 4 bits. That could be 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 0, and so on. There's a pattern, right? That's how you count in binary. Although I think I was doing that backwards for you. So you've got, what, 2 to the 8 or 8 to the 2? Whatever. You got a bunch of combinations that are possible with 1 byte, and so basically by convention, certain bytes mean certain things. So dollar signs obviously are a special character, right? A special type of byte in basically any computer system when you start to get under the hood. So to handle special characters, we have this escape character, this backslash, which will be the key next to your P on your keyboard. So you can escape things like that. Escape n means new line. So if I say print escape n, let's try that. Escape n. Sometimes you have to escape the escape key. Long story short, I tried a single escape and it didn't work. I tried a double escape and it did work. Why? I don't know. But we solved a problem. We don't have to know why our solutions work. We just need to get them to work. So, let's put that in there. Perfect. Oh, just lost. Oh. There we go. Lost my muscle memory for a second. I forgot where the hotkey was for this on this keyboard. Okay, so oops. All right. Cool. So there is table. Let's go ahead and take a look at it. So we got names, we got capacities, lengths, a bunch of NAs. These, I think, are cylindrical tanks, which might not be an efficient use of space. But what I can do here is I can create a column of floor space. But I'm going to leave that for, well, do I want to do that? Let's get dollars per gallon and gallons per dollar. What are my variable names? Capacity. I need to create capacity as a number. So use the same naming convention of a lowercase to mean the numeric version, uppercase to be a string variable. That's kind of an accidental convention I'm stumbling on here, and I kind of like it. I might use that pattern more in the future. All right, so capacity equals, I'm going to assume they're all in gallons. So if I do string remove from capacity, perfect. So notice I kind of solved this with a very similar pattern. Once you solve one problem, often you can kind of find simple duplicate ways to do that. Notice also we kind of have a pattern within this: price capacity, dollar sign gallons. This is almost something we might want to wrap into a function, and then we could just apply that function to a bunch of columns. In this case, that would be overkill, but if we were doing a lot of this type of work, that might save us a lot of time down the line. All right, cool. So, and then, yeah, gallons per whatever. All right. What do we got? We got 12 columns, and I want really the last four. That's what, 9 to 12. All right, so already, without really even getting too much of this into, a usable form for me, uh, just interacting on the console, I've already been able to look on this page, and rather than just kind of look through manually, I've limited my search to, okay, I can see what's the best bang for my buck. That's the 165 gallon tank, or really the 600-gallon tank, which was just too much. So I filtered that. 200, frankly, is too much. 165, frankly, is too much. But I've got a starting place. So that's for cylindrical tanks. Let's look at some square tanks. What I'm looking for here, I'm thinking about food trucks, and I'm wondering for a coffee trailer, how much would the water tanks cost? All right, so what do we got? Vertical storage tanks. I don't think that's what I'm after. Let's see what some of these look like. I think I'm after RV water tanks. Yeah, that, again, cylindrical. I could plug that in. Okay, so here's where I start to think about a function. How am I going to ingest a page? Cool. So I've got a way to take in a page. From that page, I get the table, make it a tibble, mutate that to get price as a number, mutate to get capacity in gallons. For the RV tanks, we're going to have length and width. I'm going to want to convert those to inches, and frankly, I can do that for all the dimensions. And actually, no, this doesn't need to be separate calls to mutate. Cool. That simplifies the code a little bit. Cool. I think that is what I need. All right, so we ingest the page, we create this data table, and then really we can just spit that out. Let's say max capacity of 150. You know what? I can do. No, I'll just ingest the page separately. I'll make a different function for, sorting through. But we take the data in, we do the mutations that we need. I'm happy with that. Let's go ahead and fold that so I can see stuff better. So ingest page. Cool. All right. have to rerun that, but whatever. All right, let's look at this more closely. Okay. It's not a double quote mark, it's 2 single quote marks. Okay, cool. All right, this is there we go. That's not too bad. Okay, these ones don't have diameters. The cylindrical tanks would. Or the vertical tanks. They've got a height and a diameter. Cool. So, I could calculate. I'm going to do this in some functions. Calculate floor space. Okay, so if there is a length, I guess let's specify. Let's say if is.na length, we should have a height and a diameter. Actually, we should have a diameter, and it should be circular. What's the area of a circle? Pi r squared. So and otherwise return length times width. Okay, I'm envisioning the function, the input in a slightly different way than it's actually taken in this case. So what I want to do, actually, can I pass it in like this? Let's try this. So if I take RV tanks if I apply on RV tanks. Okay, that's fine. All right. So what do I want to do here? I want to say So I'm using an if-else. All right, so floor space is an if-else. So if, oh, here's that mistake I had. So if the value of length is an NA, it means that I've got a cylindrical product, in which case the floor space is pi r squared. Otherwise, I can use length times width to find the floor space. Whoops, there we go. Run that, run it again. And then we can look at, let's say, RV tanks. Actually, tanks could be full join. Is it a full join, or do I just do an R-bind? Whatever, I'll do a full join. Cylindrical tanks and vertical tanks. And then full join that with RV tanks. All right, looks good. So I've got 285 tanks to look at. Let's go ahead and think about this systematically. So, tanks, let's say filter capacity is less than or equal to 150. We've got 123 options. Let's go ahead and arrange that in ascending dollars per gallon. And so my best bang for my buck is 150 gallons, 130. So the big tanks in general. This 65 gallon, that's interesting. Let's go ahead and select the columns we want to look at, which will be 9 to 17. So, price, I got capacity, I got gallons per dollar. Two more variables. Let's make this full screen so we can see it all. And floor space. So, my best bang for my buck is this guy. 30-inch diameter. Okay, that's a big old barrel. And then biggest floor space. Well, we've got 123. Right now we're just kind of looking at where do we pay $3 per gallon, which is a fair place to start. So of these, 75, that's kind of nice. Length, width, we don't have any squares here. Let's go ahead and filter to where not is.na length. So once we're looking at a rectangular tank, our dollars per gallon goes way up. That's interesting. Let's go ahead and filter so capacity is also greater than 50. And we get nothing. All right, let's say greater than 30. Nothing? 82 rows, what's our capacity? Okay, let's arrange in descending order of capacity. No, whoops. It's going to be 19. Okay, I know what's going on. So, we've solved a lot of the problems, but not all of the problems because we've got multiple pages of results here. So, oops. How many results have we got? Have we got 20? We don't. Have we got 10? We don't. Have we got 5? We don't. Have we got 3? We have 3. We got 4. I could have just clicked 4. All right, so we got 4. So we'll loop over 2 to 4. And we'll do this. So, right. Let's see if that works. Why is this being so slow? All right. And then we'll loop. And looks good. And we got 339 observations. Cool. All right. I'm going to go ahead and end on a high note. Although, yeah, what did I get here? So let's also filter not is.na length. Let's see what I got. So 416, 23 cents, or 23 gallons per dollar, or whatever. $438 per gallon. Okay, cool. So looking into the bigger capacities, 95 gallons, $438 dollars per gallon. That's better. The floor space is pretty high, but it's an interesting shape. That might be useful. Cool. So this has just been the start of me getting my stuff together here. So I'm going to go ahead and save my progress. Commit this. I got a remote. Looks like I've already set up a remote for this. This is great. Cool. All right. So I will leave that there and go find myself some breakfast. Good luck with your projects, and I'll talk to you in the future.